All right, good evening, guys. So today we are going to be covering tables and graphs, and you're going to see some stuff that's pretty similar to stuff that we've already covered in class, but there's going to be some added stuff for it, and hopefully this won't be too bad for you guys, okay? So today we're going to be actually taking some tables, and I'm actually going to be giving you equations, and then you're going to have to fill in the table just given the equation. That's it. You're not going to be given anything else, just the equation for the function, and you're going to have to fill in the table, and then you're going to have to graph the function as well. These usually aren't too bad, especially considering you've already learned about function notation yesterday. So these shouldn't be all that difficult. There will be some specific things you want to look for, though, here and there. So let's go ahead and get started. So I'm going to start with this one, and I chose not to put just a basic function like f of x equals 2x plus 1, because in a problem like that, you can just pick any given number, and it really doesn't matter what number you choose. It's going to be effective. So on this one, I'm going to choose f of x equals 1/2 x plus 1. And for the x values, I've told you this all throughout the stuff we've been doing recently. The x values really don't matter. I could pick any x value in here, and just like the function notation, I'd plug that in for x, and I would simplify, and whatever I got left would be my y value. Now, when you're dealing with fractions, though, however, you want to pick your numbers wisely, okay? You don't want to just pick any random number. The reason why is, let me actually give you an example here. And I'll do this one to start. So let's just say I picked the number 3. And I plug it in and I say f of 3 equals 1/2 times 3 plus 1. Well, now I'm going to have to do multiplication here. Well, this is 3 over 1. 1/2 times 3 over 1 is f of 3. That's going to be 3 over 2 plus 1. Now I'm going to have to get a common denominator. Actually, let me fix this. That should be a 1. I'm going to have to get my common denominator, which means I'm going to have to multiply by 2 over 2. So that gives me f of 3 equals 3/2 plus 2 over 2. And that equals 5 over 2. So the y would be 5 over 2. Well, this is fine, but you tell me. It's going to be kind of hard to graph the number 5 over 2, correct? So this is why I want to choose my numbers more carefully than I would normally, okay? So in this problem, I don't want to choose the number 3. Now I'm going to leave 3 on there, but I don't want to choose the number 3. I want to choose numbers that are multiples of the denominator. So if you remember, the multiples of 2 would be 2, 4, 6, 8, and so on. I want to pick these kind of numbers, and you're going to see why right now. And you could also pick the negatives as well. You could pick -2, -4, -6, and -8, and that would be fine as well. So let's go ahead, and I'm going to now show you why you want to pick multiples of 2. Okay, so let's say I pick -2, and let's go ahead, and 0 should be an easy one. And let's pick 2 and 4 and 6. Okay, so -2, f of -2 would be 1/2 times -2 plus 1. And I'm going to continue this, so I put this over 1, which means this is -2 over 2 plus 1. -2 divided by 2 is -1 plus 1, which is 0. So this will be 0. F of 0 is going to be 1/2 times 0 plus 1. Well, this is 0 plus 1, which means f of 0 is 1. Draw a line here so I can do the next set. So the next one, f of 2. This is 1/2 times 2 plus 1. This is 1/2. Well, hold on. Let me actually erase the 1/2. Okay. just like we did on the other one, put the 2 over 1, multiply straight across. That's 2 over 2 plus 1, which is, this is 1 plus 1, which is 2. F of 4 is 1/2 times 4 plus 1. Well, put that over 1. The 4 and the 2 will cancel, and this is 2. So now I got 1 times 2 is 2 plus 1, which is 3. And then the last one, f of 6, is 1/2 times 6 plus 1. Put the 6 over 1 again, multiply straight across, or I can cancel. The 6 and the 2 will cancel. The 6 becomes a 2. The 2 becomes a 1. So now I have 1 times 3 is 3 plus 1, which is 4. Okay? So now I have a table. Now I'm not going to use 3 and 5/2 again because it's going to be difficult to graph that number. So let's go ahead. I'm going to go over here and I'll rewrite my table. So this is 3 and 5/2. Then we did -2, 0, 2, 4, 6. And it was 0, 1, 2, 3, 4. Okay? So now I'm going to go ahead and do my axes. And for this, I've got all positives, but it is possible to have a negative. So since this is a line, we're just going to put my x and y axis right in the middle. There we go. And go ahead and put the arrows on it. And now you're just going to plot your points. So we're not going to plot 3, but I will plot 0 and -2 right here. And this should be called a what? The point where the graph crosses the y-axis is the y-intercept. And then you have 2 and 2 right here. And you have 4 and 3 right here. Oh, and I actually made a mistake. This was not 0. It was -2 and 0, which is right here. And this was 0 and 1. And then you had 4 and 3, and then you had 6 and 4, which is right here. And you should be able to tell that this is making us a line. I'm going to connect my line just like this. And again, when you're graphing, I really want you to use a ruler. So please make sure that your lines are straight and neat. And then the last thing to do is to label the line, which is done just like this. You're just going to label your points. Okay? And 4, 3, and the last one is 6, 4. Okay? So now I have my points labeled and I have my graph done. Now, you should have recognized here that the reason I chose factors of 8, or excuse me, of 2, is because it allowed me to get rid of my fraction. 3 was not a factor of 2, or excuse me, a multiple of 2, so I got a fraction here, which you can do that, and that's fine, but everybody likes working with whole numbers rather than fractions. So I highly suggest that you use multiples of 2 if it is a fraction. Now, if this was not a fraction here, then when I do the multiplication, it doesn't matter what x is, I'm still going to get a whole number. Okay? So that's number 1. Now we're going to go on and we're going to do example number 2. And again, it's going to be the same idea here. Okay? So here I don't have a fraction, so I can pick any numbers I want. So I'm going to pick, we got 1, 2, 3, 4, 5, we got 6, so let's do -2, -1, 0, 1, 2, and 3. And let's go ahead and use our function notation and plug them in. So this is -2, which gives you 2 times -2 squared minus 1. -2 squared, that's 4 minus 1. This is 8 minus 1, which is 7. Okay, and that was f of -2. Now you have f of -1. You have 2 times -1 squared minus 1. This is 2 times 1 minus 1. That's 2 minus 1, which is 1. Now you have f of 0, which is 2 times 0 squared minus 1. That's 2 times 0 minus 1. This is 0 minus 1, which gives you f of 0 equals negative 1. F of 1, 2 times 1 squared minus 1. That's 2 times 1 minus 1, which is 2 minus 1, and that equals 1. And then you do 2. You got f of 2, and that is 2 times 2 squared minus 1. This is 2 times 4 minus 1. 2 times 4 is 8 minus 1, and that equals 7. And then the last one is f of 3, and that's 2 times 3 squared minus 1. That's 2 times 9 minus 1. This is 18 minus 1, which is 17. Okay? So let me fill in the t-chart again on the next slide. So this was 7, 1, negative 1, 1, 7, and 17. Negative 2, negative 1, 0, 1, 2, 3. Alright, so let's go ahead and let's make our axes again. So we're going to put that bad boy right in the middle. Put our arrowheads. And then let's go ahead and graph the points. So you have negative 2 and 7. That's 1, 2, 3, 4, 5, 6, 7. And actually, we're going to have to go up by more than that because I have 17 here. So let's do these by 2. So you've got negative 2. You got 2, 4, 6, 8. So that's going to be right here. You got negative 1 and 1, which is right here. 0 and negative 1. You got 1 and 1. 2 and 7. And 3 and 17. So it's 8, 10, 12, 14, 16, 17, right here. Okay? And now you should recognize that this is actually going to be a parabola. Okay? And it's going to look something like this. And then you'll label your points 3 and 17, 2 and 7, 1 and 1. This is 0 and negative 1. This one is negative 1 and 1. This is negative 2 and 7. And there is no other point up there that we did. So then this would be my graph. So we used function notation. You just plug in the values. Then you graph your points and label them, and you're completely done. And this is all there is to doing this. It should be somewhat familiar, just based on the fact that we've done function notation now, and we've also done some other stuff. We did the function notation, we did the tables, we did the graphs. So there's several different things that we've already done that should look familiar in this. So I hope you guys actually do the notes tonight and pay attention, and then we will get to doing some work on this tomorrow and hopefully be ready to go. Alright, have a great night, and we'll talk to you guys tomorrow.